All right, so we have something called the mean value theorem, and mean value theorem basically states the following. Kind of don't want to use a picture on here. I want to make up my own. So let's start by writing our condition. Our condition is the following, that is, here it is. The function is continuous on the closed interval and it's differentiable on the open interval. The reason we're saying it's differentiable on the open interval is because at the end point we can't find a slope. Okay, so we want to keep that open. So if you would, let's write those conditions on the top somewhere. And mean value theorem has to do with parallelism, and our abbreviation is MVT, mean value theorem. And let's write our condition. The function is continuous on A to B, that's closed, and differentiable on the open interval A to B. And I want to make a graph on this one. And really in the end, how you make the graph really in the end doesn't matter, but I think I want to make a graph that looks somewhat extreme like this maybe. Let's say I go ahead and create 2 points, and I'm going to call this point to this point down here. And this may be going back to geometry. When 2 points are creating a line, y'all remember what that was called back in geometry? Tangent. It's kind of like tangent. What's another word for it? Any idea? You're like, that was 2 years ago. I don't remember. It's called a secant line. So if you guys want to write secant on that one. So as long as I have a continuous graph, the secant line will always have a tangent line that is parallel. And I'm going to try to make it as parallel as possible. Well, that's not very parallel. And tangent line is through 1 point. So there will always be a point where a tangent line and a secant line are always congruent to by the slope. So let's be a little more specific. I'm going to call this point A, call the other end point B, and because of the definition, let's call this one point C. So here's what the definition states. F prime of C is equivalent to F of B minus the F of A all over B minus A. Isn't that basically our slope formula, even back in Algebra 1? Yeah? All right. So we know the first part right here is our tangent line. The second part here is called a secant line. The secant line consists of 2 points. And a phrase that you're going to hear me use pretty often is the following. Tangent line happens at 1 point. It's called IROC, instantaneous rate of change, meaning it's only hitting the point on the graph at 1 point. And then from these two is the average rate of change, because I'm finding the average between 2 points. So if I tell you IROC is equal to AROC, it's simply defining this theorem. AROC. Oh, the pen is going out of ink. There you go. So this theorem we're going to use actually not just on 3.2a, but also on B. So keep this out if you haven't. So let's go ahead and fill in the blank on the top middle somewhat. The slope of the tangent line is equivalent to the slope of what? Secant line. And tangent line is instantaneous rate of change. Instantaneous rate of change. And the secant line is the average rate of change because it's consisting of 2 points. But really in the end, as long as you have this card, you're pretty much good to go. So let's go on to the second page. And do an actual example. So on the very top, Colin, let's read. Apply
the mean value theorem to f(x) equals 5 minus 4 over x on interval 1 1. Find all values of c in the interval ab such that fc is equal to fb minus fa over b minus.
And just to be extra careful, let's write out the condition. Mean value theorem is going to work out. if the function is continuous on the closed interval of a and b, and the function is also differentiable on the open interval of a and b. And I want to rewrite the function in a way that's going to be friendlier for us to use the power rule. So let's rewrite this. F of x. Now the 5 is not a problem. Do we like to have the x on the bottom if I want to use power rule? Bring it up to the top of the -1. So from there, we want to use the mean value theorem. And the mean value theorem says that IROC is equivalent to AROC. So let's all write out IROC on the left and AROC on the right. And we'll look at each piece individually and then put them together. So IROC is our f prime of x. What is the derivative of any constant? 0. What's the derivative of my second component here?
4x to the -7.
4x to the -2. And let's write this in a friendlier form just so that we have a way to set them equal to each other in the end, which I think I'm going to use cross multiplying. But let's do AROC. AROC is the right piece. So here's IROC and AROC. And we know our endpoints are given as what, comma, what? 1, 4. So we know we have f of 4 minus f of 1 over 4 minus the 1. And let's go ahead and look at the graph. When I go to my 4, what is my f of 4?
4.
Just happens to also be 4. When I go to my f of 1, that also happens to be 1 over 4 minus the 1. And that's actually going to give me 3 over 3. So at this point, mean value theorem says we can now set these two what to each other? Equal to. Now, is it okay to leave it as 3 over 3 if I wanted? Yeah? Can I just have that as 1? Which is going to make it easier. So we have 4 over x squared is equal to 1 over 1. And when I cross multiply, we get x squared is equal to 4. So how many is my x then?
2.
2. Anyone get another kind of 2? When I square root on both sides, we get plus or minus 2. But look at our interval that we're worrying about. What number do I not care about if I'm looking from 1 to 4 inclusive?
-2.
The negative we don't care about. So all I need is that x must be equal to 2. Or specifically, according to the mean value theorem, we're typically looking for c. So they're both correct. So on your test, if you get carried away and you write x equals 2 and stop, that's okay. Not going to take off for that. Okay? All right. Question.
So for the IROC, you're just finding the
Derivative.
That's the one.
You're just finding the f
AROC
prime.
is you solving for it.
You find the average.
How do you know if it's like how did you put function of 4 minus f of 1 minus f of 1? F of 4 minus f of 1, sorry. Like is it the
By the
one
definition. If b is equal to 4, a is equal to 1, you just simply
so
plug it in. And here's our our conclusion. The secant line will have another point that is congruent to the tangent line at all times. That's all this is trying to tell you. And it says our slope is what? 1. So I guess we have both slope equal to 1, so they are equivalent. All right, let's do one with a word problem that doesn't involve graph. And by that, I mean the next page. Okay, on number 5, Luke, let's read.
The company introduces a new product for which the number of units sold as is given by S of t is equal to 200 times 5 minus 9 over 2 plus t, where t is determined months.
Okay, let's be a little more detailed on the graph. I'm going to put on here t as in months. And for the vertical piece, let's go ahead and write for that one S of t. The amount sold. All right, part S, A says to find the average rate of change. Let's go ahead and underline this. Average rate of change. Is that spelling AROC or IROC? AROC. Let's write that out. And it looks like the first year. Your first year starts at 0, not at 1. Because then you're telling me month 1 is done. All the way to 12. And let's write out our average rate of change. So it's again our slope formula, S of 12 minus S of 0 over 12 minus 0. And then when I plug this in, what I want you to do is plug in our t value into the original function exactly as it is. Don't try to get creative and rewrite it because we're not looking for IROC. So 200 times 5 minus 9 over 2 plus 12 minus, now plug in the 0 in place of t. Oh, I said 0 instead of writing 5. Okay, that should be 5. Minus 9 over 2 plus 0. All over 12. Because 12 minus 0 is how many? 12. All right, I'm going to type this in. And I need someone to watch to make sure that I'm not typing in something silly. And I'm going to assume I don't know 2 plus 12. Just type it in exactly as we see it. Oh, I need parentheses. Minus. And I'm also going to assume I don't know 2 minus 0. All right. Is that pretty comparable to what I have on the paper? All right.
Well, yeah, you put it over 12.
Divided by 12. Oh, all over 12, right?
Yeah.
How about I go ahead and take this and divide it by 12 after? So we get 450 over 7. And that is the amount of units sold over the course of the month. And done for part A.
Is that saying like sold 450 units in 7 months or
Mhm.
per month?
Per 7 month. In the 7 month. All right, now let's look at part B. On part B, Mason, let's read.
During what month does S prime T give the average value during the first year?
All right, so it's saying S of T, S prime of T. Is S prime of T or IROC or AROC? So let's write on here, IROC is equivalent to the AROC. We know the AROC already, so I'm going to go ahead and write out something is equal to 450 over 7 because we found the AROC already. And let's write out the function that was given to us at the beginning. So I don't have to go up and down. And let's see how we should alter this so we can find our derivative easily. That should be 2. Okay, the first thing we should do is what? Distribute. Very good. Let's do that. 200 times 5 is 1,000. And then 200 times 9 is 1,800. Notice 200 is understood over 1, meaning your denominator does not change. I know kids want to multiply the top and the bottom by 200. That's really in multiplying by 1. And then let's rewrite this. We do not like variable in the bottom because then I can't use power rule. So let's rewrite this as 1,000 minus 1,800 times 2 minus t to the negative 1. So then I can use our rule, and specifically for this one, what rule are we using? Chain rule. So S prime of t is our IROC. So we have derivative of 1,000. Does that matter? Karis? It should be 2 plus t. Thank you. Let me write this down. So we have 1,000 is not going to give us anything, but when I multiply these two, we get positive 1,800. 2 plus t. And what's our 1 less power? Negative 2. And let's rewrite it in a form that we can use our cross multiplying. Make sure your plus and t is somewhat different. Now let's plug it in into our AROC.
Wait, that's all you have to do for that one?
For that piece, All right, let's go ahead and cross multiply. When I cross multiply, we get 450 times 2 plus t all squared is equal to some number over here. I think I'm going to let my calculator do that piece. If I can find it. So we get 7 times 1800. And since I want to get rid of our 450 divided by 450, I get 28. Can someone confirm that for me? You good? Thank you. And then what should I do on both sides? Square root. So when I do, I get 2 plus t is equal to, so square root of 28. Let's make it into 3 decimal places. 5.292. And then when I subtract 2, we get 3.292. And it says, during what month? It'll be month number 3.292. Now, here's a question that might kind of trip you a little bit. Is that at month 3 or month 4? Month 4? How many of you guys think it's month 4? What about month 3? I disagree. It is month 4. Let me tell you why. Listen. So when you're in high school, typically, how many years are you in high school? So you guys are all seniors, right? Is this your 3rd year or 4th year? Does that mean you finished 4th yet? Not all the way. It's still month 4. Good one. No one agreed with you, right? But I was like, that's a good one.